Hello, my name is Bill Schmarzo, and I am the Chief Innovation Officer at Hitachi Vantara. But today I'm going to talk to you less from the Chief Innovation Officer position and more from my teaching positions. I am an executive fellow at the University of San Francisco, and I'm also an honorary professor at the National University of Ireland in Galway. I want to share with you a lot of the stuff that we're doing in this space, really around the economics of data, analytics, and how that's driving organizations' digital transformations. But before I get into that, let me throw something at you. That is, data is the new oil. Now, what an interesting, provocative statement. For the first time since I've been in the data and analytics industry, and I've been in this industry for nearly 40 years, this is the first time I've heard a statement where someone actually associated value with data. In the same way that oil fueled the economic growth of the 20th century, data would be the catalyst that drives the growth in the 21st century. Very provocative statement. But there's much more that data has to offer, much more that it has to capabilities than oil does. And put a pin in this statement, because we're going to come back to this. And if, by the way, if you as an organization believe that data is the new oil, that data is the new source of economic growth, then you have to ask yourself this very fundamental question, which is how effective is your organization at leveraging data and analytics to power your business models? Now think about that question for a second. How effective is your organization if you believe that data is the economic catalyst of the 21st century? Then you need to think through how you're going to answer this question. Now the problem when you ask organizations these questions is that they do not know how to answer that. So in order to address that, we created what we call the Big Data Business Model Maturity Index. It's a benchmark that tells you what good looks like. If you want to know how good you are, how effective you are, well, here's a benchmark that measures you from the low end of using data to build reports that monitor the business, through the areas of predicting and prescribing and optimizing, through the stage of driving monetization around your operational customer and product insights, finally to digital transformation, where you are embedding the learning aspects of analytics to continuously learn, drive, and optimize the organization. And the one thing that you're going to learn as you will navigate this process is that this navigation, especially crossing that chasm, right there, that chasm between the business monitoring and the business insights phase, that's not a technology chasm. You can throw lots of technology down that chasm. It's just going to go nowhere. We've learned over many, many years that technology doesn't solve that chasm. To solve that chasm, you need to take a whole different perspective. You need a different frame. And that frame is around the idea of economics. What is economics? Well, economics is about the knowledge and the production of wealth, or value in our case. So if this is what organizations can do, if this is the realm of what's possible, and we could spend a whole day just talking about how does an organization navigate this maturity index, but if this is what you want to do, then the question of how you do it is a value engineering conversation. That is, how does the organization leverage data and analytics to really create value? What are the economic drivers of leveraging data and analytics? And if you want to apply this data science value engineering framework, the conversation must start with the business, not the technology. I don't want to start my conversation talking about data. I don't want to start my conversation talking about artificial intelligence and machine learning. I want to talk about what's important to the business. Is it reducing unplanned operational downtime? Is it increasing customer retention? Is it increasing freshman retention? Is it reducing inventory costs? Is it about providing better healthcare costs and better quality of life? Think about what organizations are trying to accomplish and start your conversations there. There are two reasons why I want to start my conversation there. Number one, there's money associated with that. Improving customer retention, reducing unplanned operational downtime, increasing operational efficiency, all has dollar impact. I want that dollar impact as the basis point for how we're going to drive this conversation, this value engineering conversation. But the second thing that's very important is if I know there's a business initiative we're going after, if there's something the organization is trying to accomplish from a business perspective, then I know there are going to be stakeholders involved. Stakeholders across a wide variety of business functions. And I want to bring them into the process on day one. I'm not going to wait to build a solution and throw it to them and say, is this good enough? No, they're going to be involved early in the process. And these are the stakeholders who either impact or are impacted by this business initiative. And what I want to capture from them, the secret sauce for this whole value engineering process, is I want to understand the decisions these stakeholders are trying to make in support of that business initiative. Now, here's the beauty about decisions. The business subject matter experts know what decisions they're trying to make because they've been trying to make them for years, decades, generations. Who are my most profitable customers? What products are likely to be out of stock? Which vehicles are likely to break? Right? Think about all the kinds of decisions they've been trying to make for years. The decisions haven't changed. That's the beauty of this process. The decisions haven't changed. What's changed is by virtue of the data and the analytics and the data science capabilities we have, what's changed are the answers. And so you want to bring the stakeholders into a process to identify, validate, value, and prioritize the decisions they're trying to make in order to support that business initiative. And that then gives you the roadmap for how you're going to deliver value to the organization. That's the basis point for the entire value engineering process. Identify, validate, value, and prioritize the decisions, which in many cases group into use cases. And once you've identified those high priority use cases you're going to go after, everything else falls out. Well, what analytics am I going to need? Right? What analytics do I need to build? What tools am I going to need to get? What data do I need? What is my IoT instrumentation strategy? And finally, what does my architecture and technology look like? Don't start at the bottom and try to crawl your way up and hope that you can find value. Start at the top where you know value is, and then work your way down. Change your frame. You want to change the game. Change the frame is how you look at the problem. So that's our value engineering approach, how we follow on target the kinds of value an organization can get from using data and analytics. Now, let me introduce you to a very interesting concept, the economic value curve. Now, what the economic value curve is, it's a measure of a series of independent variables and the impact those independent variables have on a dependent variable. Let's say I'm trying to improve uptime, and I can increase all kinds of maintenance, spend lots of maintenance on inventory and labor and overtime and et cetera, trying to improve that uptime. The challenge is, given my existing economic value curve, at a certain point in time, spending more money on maintenance does not give me any more uptime percentage. It's called the law of diminishing returns. Right? That's a very fundamental economic concept. The law of diminishing returns kicks in, and sometimes the more and more I spend on maintenance, I get less and less an uptime increase, and in fact, at some point in time, due to crowding out, it actually may go negative. So what's an organization to do? I can't spend and get more and get better results. What you can do as an organization is to leverage data and analytics to transform the economic value curve, to actually defeat the law of diminishing returns by doing more with less. What I mean by that is you're taking each of your dollars, and instead of spending them blanketly across a bunch of policies and decisions, you're actually becoming very laser-like. And to do that, to achieve that, do more with less, and to transform your economic value curve, you need to embrace the power of understanding the conflict that comes about naturally trying to solve problems. For example, we are currently in a situation across the world where we have a choice between economic growth and healthcare. And we can see, for example, here's a couple of economic value curves that are already in existence. Here's one for the US, which doesn't look very good, right? We can see that the US has reached a point of marginal law of diminishing returns, right? You can see that the improvements, the more and more they're spending, they're getting less and less return on expected life. And you can see other countries are actually doing a much better job. The way to solve this problem, the way to change that economic value curve, not only for the US, but for all countries, is to become much more granular about the insights we're gaining about patients and doctors and treatments. And we can use that to create, precision medicine and personalized welfare and machine learning assisted imaging diagnostics. And all these things on the left-hand side here are all driven because we have very intimate, predictive, and prescriptive insights at the level of the individual. That is right. It's big data isn't interesting because of the volume of the data. Big data is interesting because of the granularity. I can build very detailed profiles on each and every one of my patients, each and every one of my doctors and nurses and technicians and operators. I can do it on each of my treatments, each of my ER rooms across all the different hospitals. I can get very granular in understanding the propensities and tendencies and inclinations and such of each of these individual entities. That's how you change the economic value curve. That's how you do more with less. You don't make blanket treatment decisions or blanket policy decisions. You understand each individual entity, human, asset, device, right? Could be, like I said, could be doctors and nurses and patients and teachers and students. Could be wind turbines and jet engines and car engines and compressors and boilers, right? It can be at the individual level to make very granular decisions. So I'm doing more with less. And it's all driven this concept around these analytic or asset models, these entity level asset models. Here's an example, for example, of a patient analytic profile. I can build a very detailed profile on every human in the world. I can bring in all kinds of patient care data and mix it with all kinds of external data sources to create like a health score, a wellness score, a diet score, all these scores, right? And if you have any experience at all with credit scores, it's the same concept. I can build a credit score, I can build a wealth score, a diet score for everybody. And I could even create a COVID at-risk score for everybody in the world that measures how likely it is that they will catch the coronavirus. I could create a score that measures they're at risk of dying, right? Not everybody who's going to catch it is going to die. Some people who are older and not in very good shape, if they get this thing, it's not a good situation. But if you're younger and healthy and you're getting plenty of vitamin D and such, right, then your chances of survival are much magnitudes higher. So the idea here, to transform the economic value curve, we have to get granular in our focus. We need to look at each individual and build these scores that allows us to make very focused decisions regarding medicine and welfare and education and housing and all the other hard problems that our world is facing. Let me talk a little bit about the importance of thinking like a data scientist. And let's start off with a very basic fundamental definition of what is data science. Well, data science is about identifying variables and metrics that might be better predictors of performance. Period. That's all it is. Now, you can go out and buy a 600-page book that tells you all the different aspects of data science, but it really boils down to that simple point. Identifying variables and metrics that might be better predictors of performance. And the single most important word in that phrase, it's blue, it's italic, it's bold, is the word might. A data scientist has an ability to explore and embrace all kinds of might opportunities, because as an organization, if you don't have enough might opportunities, you'll never have any breakthrough opportunities. So we want to embrace this power of might. And I'm going to kind of skip through this slide really quickly, and you'll have it, but it basically says that we want to take organizations from asking descriptive questions about what happened and transform the stakeholders into thinking about making predictive questions. For example, I guess I'm going to spend more time on this than I thought, right? So I asked questions today about what were revenues and profits last year, but I'd like to understand what will revenues and profits likely be next year, and what variables and metrics might I need in order to make that prediction. Think about that for a second. What will revenues and profits likely be next year, and what variables and metrics might I need to make that prediction? The power of might is critical because we're going to leverage might as part of our data science process to explore which of these variables and metrics are actually better predictors of performance. And the one thing that we've learned through this very rapid exploration, testing, failure-centric, continuous learning scientific method is that the best ideas of what variables and metrics might be the best predictors of performance doesn't come from the data scientists. It comes from the business subject matter experts who are living the job, who've been doing it for years or decades, right? They understand the business. And what we do is we marry the subject matter experts and their ability to freely think, to think outside the box, with the data scientists who have all the right tools to really not only to identify those variables and metrics that might be better predictors of performance, but actually show and prove which ones are. And that requires we take the business stakeholders, the business subject matter experts, the executives in a lot of organizations, and teach them how to think like a data scientist. We need to break open the way they think, the way they approach problems, and embrace the power of ideation. Embrace the power of all ideas are worthy of consideration. Embrace the power of failure. You can't learn if you're not willing to fail. And failure is a hard concept in most organizations because failure is a mark of failure, right? No, failure, especially in the data science world, is a mark of learning. If you don't have enough failure moments, you're not pushing the edges. So we teach everybody to think like a data scientist, to open up the mindset so we can identify those variables and metrics. And it all gets encapsulated, by the way, in this hypothesis development canvas. This is a tool that we use to make certain that there's alignment between the business subject matter experts and the data scientists before we ever put science to the data. We go through all of this work on paper, brainstorming, lots of design thinking techniques, post-it notes, a lot of people, creative ideas coming up, prototyping with little flip charts and such. But we do all of this before we ever put science in the data. That helps us make certain that our data science is focused in on the right problem. We know the KPIs and metrics against which we're going to measure success and progress. We know the entities around which we're going to build the analytics. We know what decisions we're trying to make and what predictions we're going to make. We know what sort of data source we might want to explore. And of course, we understand the costs associated with false positives and false negatives. Because if you don't know the costs of the false positives and false negatives, then you never know when your analytic model is good enough. So let's talk about the economic value of data. And I got to tell you a story here. So as I mentioned before, I've been in this industry a very long time. And one of the challenges I have, one of the holy grails I've sort of chased after all my entire life is, how do you put value on data? Now, I've got to tell you, my conversation on the value of data always started with thinking about, if data has value, then I must be able to put it into a balance sheet. Because I can put it into a balance sheet, then I can reflect the value of data to the organization, to the stock market, et cetera, et cetera. So I had this fixation that data had to fit into this traditional sort of mold of being able to put it on a balance sheet so I could then give it value. So we tackled this project at the University of San Francisco. And the advantage of being a professor is I have access to a lot of very smart, a lot of energetic, a lot of free resources who can go after this problem. And so we tackled this problem. And my challenge is thinking about, how do I get data on the balance sheet? And I had that fixed mindset until one of my researchers came up to me, and what she said is, Professor Schmarzo, this data is kind of an unusual asset. I said, what do you mean? She said, well, data never depletes, never wears out, and the same data set can be used across an infinite number of use cases at zero marginal cost. When she said zero marginal cost, I started thinking, oh my gosh, my mindset has been wrong the whole way. This is not an accounting mindset that tries to determine the value of data by which somebody's willing to pay you for it, or what we call value in exchange. This is an economics mindset, where I'm looking at the value of data and how I use it to create new value. It was a whole different perspective, and it really opened up this idea of economics. And of course, the economic multiplier effect jumps in here dramatically. That the fact that I can reuse this data over and over again starts to get to a point where the marginal propensity to consume starts to approach one. As it approaches one, of course, the economic value approaches infinity. And as an example of what this means and how this multiplier effect works, let me show you a simple example. Let's say you got customer point of sale data. And what you want to do, dramatic pause. I wish I had a beer. Let's say that you're going to use that customer point of sale data, and you're going to use it in your sales organization to improve promotional effectiveness by 2.5%. Now, I don't know how much 2.5% is. Maybe that's 100,000. Maybe that's 5 million. Maybe it's 25 million. Depends on the size of the organization. But what I know is this: there's value. Financial, economic value associated with using that data set to improve promotional effectiveness by 2.5%. Okay, that's great. I can associate value to that data set. But wait, there's more. The marketing folks can use that same exact data set, as is with no changes, to improve customer acquisition by 2%. Now, again, I don't know what 2% is. Is 2% 10 million, 15 million, 50 million. Again, I don't know, but I know this. They get the benefit of improving customer acquisition by 2% at a marginal cost equal to 0. It doesn't cost them anything to reuse the data. You don't have to go out and rebuild it all over again. You don't have to go out and build another data lake. The data is already in my data lake. I can now use it again at 0 marginal cost. You can start to see what happens here. I can reuse this data set over and over and over again for each different use case by use case, which each use case has financial value, and that data set can drive that value. Now we're talking about a way that I can really attribute value to my data. And I'm not doing it through an accounting mindset. I'm doing it through economics. Now, as we did this research, 2 things jumped out at us, 2 really problem areas. Number 1, data silos are bad news. If I can't share the data, I can't monetize it. That's pretty straightforward. The second thing we came across, at the time I didn't understand this, was this concept of orphaned analytics, which is organizations who were very good, very advanced in doing analytics, would build analytics to solve one-off business problems, but never reuse the analytics over again. They worked great. They got the sort of a great one-time hit from it, but they never reuse it over and over again. They just did it once. They were so good at analytics, they just did it once and moved on. I didn't understand the significance of orphaned analytics until later. We'll get to that point. So let me walk through how this works, right? You think about the use case by use case approach. The use case tells me what data sets I need and what data sets I don't need. The use case tells me what analytics I need and what analytics I don't need. And I can use the use cases to drive the build out of my data assets and my analytic assets. Kind of works like this, right? So think about, let's say my first use case is around vendor reliability, right? So what I'm going to do is, in order to build, let's say vendor reliability is worth $60 million, and I go through the process and realize I need 3 data sets to solve that problem. That problem's worth $60 million. Each of those data sets, I can allocate $20 million to each of them. Now, if I want to get really fancy and use something like random forest or PC, I could get more granular, but it's good enough, right? So, and by the way, I need to build two different sets of analytic modules. Module A is an anomaly detection module that flags problems, and module B builds a reliability score on each of my suppliers. Okay, that's great. So that's those 3 data sources and those 2 data sets are delivering $60 million in value. Use case number 2 is around vendor quality. Okay, first one was reliability, this one's quality. And this one, let's say it's worth $40 million. Now here's what's interesting. I need 2 data sets for this. Data set A, I'm going to reuse before. I don't have to pay anything for it. It's reused. I just need to build one new data set D, and I can allocate the value to $20 million or $40 million to each of data sets A and D. So A gets another 20 million after getting 20 million in the first case. So they're delivering $40 million in value. In use case, data set D is delivering 20 million. I think you understand the process. And by the way, the same thing with analytic assets. I'm going to reuse the anomaly detection, but I'm going to build one now around vendor quality, of analytic model on vendor quality, right? And you can see how this process works, use case by use case. I'm reusing data sets and sometimes adding new data sets, and I'm allocating the value down and of the data sets, and I'm reusing my analytic assets, and where I need to, I build new ones. Right? Makes sense, right? Like I showed earlier. But wait, there's something special about this. What if, in use case number 3, one of my big giant brained data scientists takes a look at that anomaly detection module and finds a way to make it 1% more efficient, 1% more predictive in its ability and its accuracy, right? They're maybe using new data enrichment techniques. Maybe they're using better hyperparameter optimization. Maybe they're doing some data munging. Whatever they're doing, they've created a way to make that module 1% more accurate in its predictions. That improvement of 1% improvement ripples back to each of the use cases that use that. They all of a sudden just got 1% more effective and ripples back up delivering value. That's a game-changing concept that no one has figured out better than our friends at Tesla. And the whole frame of this, how do you build analytic assets that appreciate in value through use, not depreciate, is a very provocative statement. I love this statement from Elon Musk because it makes you stop and think for a second about when you buy an asset, in the accounting mentality, when you buy an asset, you put together a depreciation schedule and you start writing off the cost of that asset. Well, Elon Musk's saying that you buy a Tesla, it's not going to depreciate. It's going to actually appreciate in value because it's becoming more intelligent. The more you drive it, the smarter it's getting, the more reliable it's getting, the safer it's getting, right? The more predictive it's getting. These assets are getting smarter, and they're appreciated in value because of the idea around artificial intelligence. Artificial intelligence allows us to build assets that as they interact with their environment, they get smarter and richer. They're continuously learning. They take an action, they see the result of the action, they learn from that, or get a reward or get a penalty. They adapt, they adopt, and they iterate through. So think about this. They're constantly trying. An AI agent is constantly trying new things. They sit within a certain state of the environment. They take an action. They measure how effective that was. They adapt based on that. They learn, and they do it again and again. So you have these AI agents that are continuously getting smart. So think about a Tesla car, right? A Tesla car is basically, for one part, it's one big giant IoT platform with all these different edge devices on the tires, on the engines, on the, right, every part of the car, and the heaters and the coolers and everything in the air conditioning. They have a bunch of IoT sensors and devices, and it's continuously capturing data, learning, and getting smarter. And it's feeding that learning to the brain that resides, the AI brain that sits inside of each one of these cars, who's continuously learning. As that car is driving down the street, it's getting smarter. As it passes a pedestrian, as it passes a bicyclist, as it stops at a stop line, as it sees a water puddle for the first time, doesn't know how to navigate it, right? It's continuously learning. That car is getting smarter. That asset is appreciating in value the more it's used. But there's even more to this. Every night, all the learnings from all the 500,000 Tesla cars are rippled back to this giant brain in the sky that runs simulations and all this stuff, and then feeds back all the learnings back to the car. These cars are continuously getting 1% better, continuously every night getting better and more efficient. And you only need to realize the power of this. You start thinking about the law of compounding. If I take a 1% improvement and compound it 365 times, at the end, I have a 37.8x improvement. Excuse me, I get so excited, I run out of water. This is a game-changing concept that we can leverage artificial intelligence and the economics of the data that never depletes and never wears out to build assets that get more valuable and the more they're used, that they're continuously learning. And that brings us to a very important concept. I think this is a game-changing concept going forward. You think about how organizations are going to be successful in the future. I'm going to argue that the economies of learning are more powerful than the economies of scale. That your ability to succeed in the future is more determined by your ability to experience, learn, adapt, and re-optimize than it is about your ability to build out giant walls, build out giant factories. Doesn't going to come from economies of scales. It's going to be able to look at what's happening in the marketplace, in your environment, in society, across the environment, and learn more quickly and adapt, relearn, and constantly re-optimize. And what's happening, these economies of scale are going to, especially in knowledge-based industries, we're going to see the economies of learning dwarfing the economies of scale. In knowledge-based industries, the economies of learning are more powerful than the economies of scale. And soon every industry is going to become a knowledge-based industry. So let me summarize everything in this one chart. This is called the Schmarzo Economic Digital Asset Valuation Theorem. It's my feeble attempt to try to get myself a Nobel Prize in how the economics of data and analytics are going to transform industries, right? So think about there's three effects that are built around the Schmarzo Economic Digital Asset Valuation Theorem. So on a use case by use case basis, what's going to happen as I go use case by use case, like we talked about throughout the presentation, and my ability to reuse data and reuse my analytics as assets, my analytic modules, my analytic assets, what happens by my ability to reuse the data and analytics, I start to flatten out my marginal costs. At some point in time, I have the vast majority of data I'm going to need, and at some point in time, I probably build out most of the analytics I'm going to need. So my marginal costs are flattening out. But that's complemented by the fact that my economic value is going to accelerate or grow, because by reusing my data and analytics, I can shrink the time to value and de-risk projects or use cases. That is, that if my first use case to develop takes 9 months, maybe the second one takes 6, and then it takes 4, and then it takes 3, and then all of a sudden maybe I'm doing 2 simultaneously, and then I'm doing 3, and then I'm doing 6 simultaneously. So I can get more reuse out of my data and analytics, which shrinks my time to value and de-risk projects. Now, if we stopped right there in those 2 effects, life would be good, and we would be happy with life. And we'd say data and analytics they're paying for themselves, and they're generating all kinds of very positive economic value for the organization. And then we get this effect where every time I improve my analytic module, every time I make it more efficient, I improve its operational efficiency. If I improve its predictive capabilities, I improve its reliability, I improve its speed. Every time I modify one of these analytic modules, the benefits of that improvement ripple back to every other use case that use that model. And it just got better. I call this the Google TensorFlow effect. Now, why do I do that? A little story, as you could probably guess. The single most profitable business in the world is Google's search business. It is truly a license to print money. And the technology that drives all of Google's search business is a technology called TensorFlow. It's a machine learning AI framework that they use to drive not only their search business, but it drives all the Google businesses, their retail business, their phone, everything that Google does, their mapping and such, everything is driven off of TensorFlow. And so what does the traditional organization do if they have an asset like TensorFlow? Well, they build protective walls around it, and they make sure they've got all kinds of IP patent around it, and they don't let anybody at it, except Google. Google's playing a different game. They've figured out something that most of the world hasn't figured out. So what does Google do? They open source it. Of course, most of the world goes, what? Why would Google ever in their right mind open source TensorFlow? Here's the reason why. Because the economies of learning are more powerful than the economies of scale. Having everybody out there using TensorFlow across a wide variety of use cases ensures that TensorFlow is always getting smarter. It's appreciating in value through the more people who use it. And the organization who believes that they know how to use TensorFlow better than anybody else is, of course, Google. So these are the 3 effects. Again, in my attempt to get a Nobel Prize, maybe someday you'll see me walking around with one of these things hanging off me, right? But this is a game-changing idea. And what's so frustrating for me is I talk to organizations how few companies really understand the value, the economic value of data, an asset that I can reuse over and over again without ever depleting, without ever wearing out, at a marginal cost equal to 0, and my ability to build analytic assets that get smarter, that appreciate in value the more they are used. Let me just sort of wrap up here by bringing all this together and show you how we could leverage everything we've talked about to actually attack this COVID-19 problem. It isn't impossible. In fact, it's really quite sensible about how we would leverage very detailed profiles, how we would transform the economic value curve. I didn't talk much about design thinking, but you sort of see how design thinking is wedded throughout the entire data science process, how I could get people to think like a data scientist in order to create these economic values, these assets that appreciate the more they're used. That each of these COVID at-risk scores could get smarter and smarter the more that we use them. This is how you apply that. This problem's not impossible to solve. In fact, it's very manageable, but you need to think differently. And maybe the biggest challenge I'm going to lay out for you here. Now, I know you're young and you're just embarking on your career, but I'm going to tell you one thing. The biggest challenge you're going to face in your life as you go forward is your ability to unlearn old concepts in order to embrace new concepts. It's been my personal challenge. My whole University of San Francisco challenge in learning about the economic value of data was basically about unlearning a lot of things I held as gospel and realizing that those things are holding me back. So I hope in conclusion here that all these things, they make a lot of sense. But the most important thing you walk away from here is that be willing to try new things. Be willing to accept different perspectives. If you've run into somebody who's got a different perspective, a different idea and rationale about why they're doing something, don't just write them off as being another kook. Embrace that. Look for opportunities to learn from others, to merge and blend those learnings, and to let go of things that are no longer serve you so you can embrace new things. Thanks very much for your time. Cheers.